Hey, all my calculus geniuses. This lesson, we're going to start looking at the derivative. So that's a big main idea that we see in calculus a lot. And I'm super excited to get started with it because it's kind of fun. So the first thing that we're going to look at is called the difference quotient. And so let's just kind of get a little bit better feel for where it comes from. So let's just pretend like I have some function here. Excuse my crooked lines. And so here's my x and y axis. So let's draw our function here, f of x. Here's our function, f of x. So remember on the x-axis, if we have something here, let's say we have an x value here, then this point on my function is going to be x, comma, f of x. So whatever x is and f of x, the function value would be the y coordinate. And then what we have here is if we have another point on this line, okay, we don't know necessarily what that is. So what we're going to say is that we are going to say that this distance from here to here is h. So this x value down here is going to be x plus h. So therefore, this coordinate is going to be x plus h, f of x plus h. So what the derivative is the derivative is a slope of the tangent line. Well, let's just have our little line here. Let's look at the secant line right here. So this right here is the secant line going from x to x plus h. And then if what we want to do is we want to get the slope of that tangent line. So what we'll do is we're going to make another secant line maybe a little bit closer and a little bit closer until, found that tangent line. So what two values? So what we're looking for is we're looking for the slope. So I have to have, so I'm going to try to find 2 points. So if I have 2 points, basically like right next to each other, trying to find that secant line essentially. And what happens is that secant line gets closer and closer and closer together until it's the same point, and then you have your tangent line. Well, what happens is that's what happens when h starts approaching 0. So that's why I had to do the limit first. So let's take a look at this. So remember that the slope formula, okay, which we call m, is the change in y divided by the change in x. So if we have 2 points on our function there, then, and we've already named them, then we can find the slope there. So it's a change in y, so it would be f of x plus h, whatever h happens to be, and then minus f of x, so those are the change in y, divided by the x value that goes with f of x plus h, which is x plus h, minus the x value that goes with f of x, and then simplifying that, we end up with f of x plus h minus f of x divided by h, because these two x's subtract out. So here we have our slope. So this would be the slope between any 2 points on our function there. We want to find out when h gets really, really, really close, it gets really, 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 really small and approaches 0. That's also known as the limit as h approaches 0, which we just looked at. So the difference quotient is the limit as h approaches 0 of f of x plus h minus f of x divided by h. And so we're going to have to do some simplification, and you've seen a couple of these problems on your tests and other practice problems getting you prepared for this moment, finding the derivative. All right, so let's take a closer look. So this function here that's graphed is f, and we're going to, that's a negative x squared minus 4x plus 1. That's what this function here is, graphed. All right. So what I want us to do is we're going to find the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Okay. So we're going to find that limit, which would give us the derivative. So this is going to be the limit as h approaches 0 of negative x plus h squared minus 4 times x plus h plus 1 plus x squared plus 4x minus 1. So I went ahead and changed all the signs of everything in f of x, which is basically what we do when we subtract f of x, all divided by h. So therefore, we're going to have the limit as h approaches 0 of negative x squared minus 2xh minus h squared minus 4x minus 4h plus 1 minus x squared, plus x squared plus 4x minus 1, all divided by h. Essentially, what you want to look for that happens every time is that every term that doesn't have h in it kind of subtracts away. So if you end up with something that doesn't, that's not necessarily that you did anything wrong, but just go back and double check. So the limit as h approaches 0, so you can see my x squareds are going to subtract out, my 4x's subtract out, and my 1 subtract out. So I'm left with negative 2xh minus h squared minus 4h, all divided by h. And what happens is that you could factor out an h, or you could kind of just take this, go ahead and divide them out. And then I'm going to go ahead now, I can substitute in because I don't have 0 in the denominator. So I'm going to have negative 2x minus h minus 4. That's the limit as h approaches 0 still of that. So I'm going to replace 0 in for h. So it's negative 2x minus 0 minus 4, which happens to be negative 2x minus 4. So this limit right here, okay, is the derivative of negative x squared minus 4x plus 1. So we would also name this, it's also called f prime of x. So that's the derivative. That's one notation that you can use to find the derivative. So this equation here. So what does this really do and how does it help us? Well, so now it's a function essentially, right? So this function allows us to find the slope of the tangent line for any value of x where f of x, where x is defined over f of x. So the derivative is the slope of the tangent line. So when I find this, if I find any value, I can find the slope of the tangent line at any value of x that I want instead of having to plug it back in. So this is called the difference quotient. All right, so we're going to find the derivative of each function here. So we're just going to start out by listing the difference quotient. The limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So this is going to be the limit h approaches 0 of 1/2 times x plus h squared minus 2 times x plus h plus 3. And then remember, when I subtract, I just change the sign of everything of f of x. And then all divided by h. So I'm going to end up now with simplifying this. Now I have So now I'm going to go through and subtract out my like terms. I say combine like terms, but it really ends up just subtracting out. So I went ahead and wrote it with h factored out here. And so that way it's easier to see. So this is going to be the limit as h approaches 0 of x plus 1/2 h minus 2, which is actually the same thing as x minus 2 because h ends up being 0. That's the derivative there. All right, so we're going to find f prime of x here. So that's going to be the limit as h approaches 0 of 2/3 times x plus h plus 3 minus 2/3 x minus 3 all divided by h. So now distributing and simplifying like terms. So what you'll notice here is that the derivative, which is the slope of the tangent line. So whenever I say derivative, you say slope of the tangent line, and when I say slope of the tangent line, you say derivative. So it's like a little cheer we can have going on here. So remember that the slope of the tangent line of a linear function, so 2/3 x minus or plus 3 is a linear function. So the slope of the tangent line is going to be infinite. So it's always, I say that it's going to be a constant. It's always going to be 2/3 because we have a linear function here. It's not going to change when we have a curve, is when our slope can change and kind of flatten out and then increase and decrease. So that's why with a linear function, you're just going to have one here where your slope is just going to be the derivative is going to be a constant because it's never going to change. The slope of the tangent line is never going to be anything other than the slope of the linear function. All right, so this one is a tricky one because we're going to have to use the conjugate. I know, so blah. So let's look here. So we're going to have the limit. So f prime of x, let's go ahead and write it out like that. F prime of x is going to be a limit as h approaches 0 of the square root of x plus h plus 2 minus the square root of x plus 2 all divided by h. So then I'm going to have to multiply by the conjugate. So I'm going to have to multiply by the square root of x plus h plus 2 plus the square root of x plus 2 and then divided by that again. And so that gives us the limit as h approaches 0 of x plus h plus 2 minus x minus 2 all divided by h times all of that stuff. Ugh. So the limit as h approaches 0. So these all subtract out nicely, and I'm left with h. H divides out here. So I'm really left with 1 over the square root of x plus h plus 2 plus the square root of x plus 2. And then h approaches 0. So this is 1 over the square root of x plus 2 plus the square root of x plus 2. So the coefficients of those are both 1. We kind of treat those like a variable. So it's like 1 over 2 times the square root of x plus 2. And so that is f prime of x. That's the derivative. Ooh. All right, so this time what we're going to do is we're going to find the equation of the line that is the equation of the line. So this time, for example 4, we're going to find the equation of the tangent line when x is -1. So let's take a look here. So what we're going to do first on ones like these, you're going to go ahead and find the functional value first. So I'm going to find f of -1 first. So that's going to be 3 over negative 1 minus 2. So that's 3 over negative 3, which equals negative 1. So my point of tangency is going to be negative 1, negative 1. Now I need to find the slope of tangency, which is actually the slope or the derivative. So I need to find f prime of x to find the slope of that tangent line so that I can write the equation, because I need a point and I need a slope to write the equation. So I'm going to have the limit as h approaches 0 of 3 divided by x plus h minus 2 minus 3 over x minus 2 all over h. So then I'm going to find a common denominator in the numerator. So I'm going to multiply this times x minus 2 and multiply this by x plus h minus 2 to get a common denominator. And so now I'm going to have the limit h approaches 0. So kind of doing some simplifying here. And then I'm going to pull out the denominator. So then this is going to divide out. And when I plug in 0, that becomes, this denominator becomes, this is going to be negative 3 over x minus 2 times x minus 2, which is negative 3 over x minus 2 squared. This is multiplied by itself. So here's the derivative. So now I need to find the slope of tangency. So I didn't leave very much room here. So I'm going to have to come up over here. So I have the slope of tangency at x equals negative 1. So I need to plug in negative 1. So I'm going to need to find f of negative 1. So this is going to be negative 3 times negative 1 minus 2 squared, which is negative 3 over 9, which ends up being negative 1/3. So now I have all that I need to find the equation of the tangent line. So this is going to be y plus 1, point slope form, is equal to m, which is negative 1/3 from here, times x minus x1, which is minus a negative 1, so it ends up being plus 1. So these 2 points come from here, x1, y1, point slope form, and then negative 1/3 came from the derivative at when x is negative 1. Whew. Okay. So you can use the difference quotient. So if it tells you you have to use it, or use the difference quotient to show whatever, then you would need to use this, the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. If it doesn't specify the difference quotient, then you can use the limit as x approaches a. So like if a, like your one up here where we were trying to find the equation when it was negative 1, it's f of x minus f of a divided by x minus a. Since we know one end of it, the point, let's see, the negative 1, like in example 4, since we knew the x value, that's whenever you would use this one here, okay? So lots of information to take in with the difference quotient. And it's a big, big piece of calculus, and I am excited to get started with it.